guys. All right. So, little review. General form, that's what it looks like. Standard form or vertex form, that's what it looks like. Okay, these are on your formula sheet. Don't have to remember it. Yesterday, I did standard form and convert that to general form. That's not too bad, right? If I take this thing and I FOIL it, expand it out, make it look like that, okay, get rid of the brackets, that's not too bad. But going this way, that's a little trickier, okay, converting from general form to standard form. So, a little bit of review. We've done this, okay, you actually got introduced to this stuff in grade 10. Those are perfect squares. Are we happy with that? What's the definition of a perfect square? Is 16 a perfect square? Because there's something multiplied by itself to give us 16, that's a definition of a perfect square. Okay? Can you take the square root of it and it be something nice? Yes, it's not irrational. That's your other choice. Okay? Like yesterday, remember there's two answers here though, isn't there? What's negative 4 times negative 4? That's supposed to be an arrow. That's also 16, right? So that's another choice. Okay, is there something multiplied by itself to give us that? Yes, x plus 4 multiplied by itself gives us x plus 4 squared. So that is a perfect square. Last year, I would have called it, oh, and this year too, a perfect square trinomial, all right? It's not necessarily a trinomial, okay? That's just a binomial squared, okay? But that's a perfect square. That's a perfect square. Can I take the square root of it? That's the other way you're going to ask yourself. Yeah, it's x plus 4, right? We just did this yesterday. Okay, expand the following perfect square. So what is this thing? Remember, that's not x squared plus 16. You got to FOIL it. Your first step is to write it like 4 squared. We know that's 16. But what does that mean? It means 4 times 4. Okay? So write it by itself. That's x squared plus 4x plus 4x. Okay? Plus 16. We know how to do this. Let's just do one more. First thing you want to do is write it like that. X squared plus 7x and 7x. 14x and 49. Okay? That's what a perfect square binomial becomes when you FOIL it. Okay? So, factor. Well, how would I factor that? I want to find two numbers that multiply to 9 and add to 6. What are those two numbers? X, 3 and 3, right? Okay, so I got x plus 3 and x plus 3. But isn't that a perfect square trinomial? And again, you can recognize that by looking at the middle term. Is this thing 2 times the square root of that times the square root of that? Yes, it is. That's a perfect square trinomial. Okay? Shelby, sit somewhere else, please. Okay? Well, let's look at this guy. Is that a perfect square trinomial? Is 12x 2 times the square root of x squared times the square root of 36? That's a lot to digest, right? Is this thing 2 times the square root of that times the square root of that? Is that 2 times this is x, this is 6? Is that thing 12x? Yes, it is. So then that's easy to factor. All you do is go x plus 6 times itself. Okay? Perfect square. So why are we doing all this stuff? Well, hopefully we maybe see a little bit of a pattern because we want to get this. When I'm converting this guy into that guy, I need to get one of those. What is that? That's a perfect square. It's x minus p squared. Okay? So let's see if we can see a little pattern. How do I get from 6 to 9? Like, what do I do to a 6 to make it a 9? Add something, multiply it by something, subtract something, divide it by something. Anybody see what that is? Show a hand if you do. Don't yell it out, Dannon. Okay, 4 of you do, 5 of you do. Let's see if it works here. Before I say what it is, does that same pattern work here? Okay, well then our pattern doesn't work. How do I get from 12 to 36? It's not simply multiplying it by 3. Okay, there's something else. There's at least 2 steps there. Anybody? It's got to work here. It's got to work here. It's got to work here. It's got to work there. No? Okay. Well, I'll tell you. You knew I was going to anyway, didn't you? Okay. What if I go and take half a 6? What's that? Okay, how can I get from 3 to 9? All right, let's see if it works. What's half of 12? Oh, I got dyslexic. What's half of 12? 6. What's 6 squared? Is that 36? All right. What's half of negative 16? Negative 8. What's negative 8 squared? That's what we're doing. That's how we complete the square. Okay? What does this need to be for it to be a perfect square? What did I do to get from 6? Let's pretend the 9 wasn't there. How did I get 9? I took half of this and then I squared it to get 9. So what's half of 2? What's 1 squared? Is that a perfect square? Okay, well, let's go the old way. What two numbers multiply to 1 and what add to 2? 1 and 1. Hey, it's a perfect square. Let's double check it by foiling, because that's our first one. Right? X squared, check. 1x and 1x is 2x, check. 1 times 1 is 1. Cool, we're done. I made it a perfect square. How do I do it? What do I do? Half of 18 is 9. Square it. That's a perfect square. That's x plus 9 squared. Okay? A little trickier, exactly the same procedure. What's half of 3? We want to leave it like that. I know that's 1.5. We don't want decimals because it's easier to square it if we leave it as a fraction. What's this thing squared? Well, this applies to everything in the brackets, so I square the top and I square the bottom, and that's what that is. Okay, it's ugly, it's a fraction, but it's still fine. Now, how do I factor this guy? Have we done one like this? I don't think so. How do I know what that number is? How did I know what this number was? Well, that one's bad because it's all ones. How did I know what this number was? You remember this divided by 2? That's what this number is in the last bracket. Okay? So how did I know what this number was? What was this divided by 2? That's the number in the brackets. Okay? Let's check it. See if it works. X squared, check. Minus 1.5x minus 1.5x. How many x is that? Is that minus 3 raised? Check. Negative 3 over 2 times negative 3 over 2 is positive 9/4. Okay? That's all we're doing. Okay? It's ugly because it's a fraction, but we can still do it. Let's not worry about that. Okay, completing the square. In general, you always, this is what we did. Okay, this is just, I don't know what b is. Well, you don't need to. Take half the coefficient of the x term, that's b, then square it. Okay? Half of b, or if you like, b over 2, squared it, and then you just write it there, and then it's a perfect square. Okay, this isn't as helpful, I don't think, as looking at a concrete example. Okay, so again, there it is. You like flowcharts? I've said it 4 times. Let's make it 5. Take half the numerical coefficient of the x term and square it. Okay? Express this in completed square form. That was the examples we just did. What am I missing here? Where does this go? He goes over there. Okay? All they did was just leave a little space. That's this equation. What goes here? How do I complete the square? What do I do again? Take half of the coefficient of the x term, half of 10. What's that? 5, and then I square it. Okay? But I can't just do that. That's going to change the question. Okay? I can't change the question. That's what it is. What can I do to this so that I didn't add 25? Add it, and then now is it the same thing? Yeah. Check. I gotta have this, x squared and 10x and 16. X squared and 10x and 25 minus 25 plus 16. Is that the same as this? Sure it is. But why do I do that? What can I do with this? Is that a perfect square trinomial? Yeah. I can write it like this. That's what these first 3 terms are, right? Okay. Let's check it before we go on. X plus 5 squared is, picture this thing twice, okay, this will be hard for some of you to do visually. X squared and 5x and 5x, that's 10x, and 5 times 5 is 25. That's the same as this. I still have this. I still have this, but can I collect these together? Yeah. Okay, what's minus 25 and 16? Minus 9. Okay? So this is our little trick. We're going to add it to get this, just like we did here. Okay? What do I need to add to do that? But I've already got a number there. I can't just change this thing. Okay? So I need to add it and subtract it. So I don't change it, and then I still have my 16. Okay? Form a perfect square. Done. Write it in factored form, and when they say simplify, well, there's 2 numbers. Just collect them to give you 9. Is this now in standard or vertex form? Do we like it in this form? Yeah, because that tells you where the vertex is. Okay? This doesn't tell you nothing. General form isn't helpful until we do quadratic formula, but in 2 days. Okay, you're going to love that. All right, vertex form. Let's not worry about the graphing calculator. A couple of you don't have it. Okay. Well, actually, that's a good. Let me do it. So if I'm going to plug in my original formula, why would I want to do this? Well, so I can find the zeros, right? There they are. What happens if I plug this guy in? If it's the same graph, identical, should I see 2 graphs, or should I see the same graph on top of the other one so it'll look like one graph? It's the latter. Okay? So if I plug in this guy, bracket x plus 5 bracket squared minus 9, How many graphs do I see? Okay, it's right. I've graphed both of these. They're just right on top of each other, which means I did it right. So can you check this if you have a graphing calculator? Yes, you can. Okay, this is the same as that. Identical. Has the same zeros, same roots, same a value. What is a? A is 1. Okay. Does it open up or open down? They're both positive. Open up. Okay, it's identical. Okay, one more. That's it. Here's a function. Determine the minimum value. How could I determine the minimum value? What happens at the minimum value? Is that another word for the vertex? Yeah. So I want to put this thing in vertex form, then I'll know where the minimum value is. How do I put something in general form, in vertex form? It's a process called, what did I just do? Completing the square. Okay, so I got an f of x. I don't like that. Let's just make it a y. Okay, nobody likes functions. X squared minus 9x. Leave a big space. Minus 20. What do I want to do? How do I complete the square? I'm going to take this, the coefficient of the x term, I'm going to divide it by 2, and then I'm going to square it. This one's ugly. I don't want 4.5. I want to leave it like that. Okay? I want to add that. That's 81 fourths. But I can't change the question. I can't change the quadratic and make it a new one. What do I need to do now to make sure it's not a new one? I got to subtract it. The same thing. Now is it the same? Yes, I didn't change it, right? I can add this, take it away. That's gone. It's the same thing. But why do I do that? Because what can I do with the first 3 terms? I can make that a perfect square. X minus, what do I put here? There's your clue. Okay? 9 over 2 squared. Now I have to collect this and this. We want it as a fraction. Don't make it a decimal. I know we all love fractions. How do you add negative 81 fourths and minus 20? Anytime you add fractions, you need a common denominator, or minus them, you need a common denominator. Okay? So that means that thing's over 1. I need to make it a 4. How many times does 1 go into 4? It's not a very good one. Is that all you got? Of course you did. You like everything. 4 times 20 is 80. 20 over 1 is the same as 80 over 4. What's minus 81 fourths minus 80 fourths? Minus 161 fourths. Where's my minimum value? What's my vertex here? Vertex is it minus or positive? 9 over 2 minus 161 4. My minimum value is this value. That's the y coordinate of my vertex. Where's my axis of symmetry? Doesn't ask it. Isn't that the x coordinate of my vertex? Okay, just because we just did a quiz and maybe that was one of the questions. Okay, so to answer the question, what's the minimum value? That's all I need. Doesn't say really put it in this form, but if you do, that's what helps us answer the question. Okay, 1 to 4.